Oh, yeah, this is fine. Well, it's very interesting. Sorry, everyone is like my whole
Scientific notation is kind of self-explanatory in that why you do it, because in the world of science, you talk to Mrs. Stone about some of the things, because things in the world are so absolutely ginormous. You look at the solar system and all of that, and some things are so incredibly small, like atoms and quarks or whatever those sort of things. We have to have a way of working with numbers when they get that big, so it's not so confusing, just because it's really difficult to multiply something like 1,800,000,000, or whatever that is. What is that number? Billion, billion, 1,800,000,000. If I was asking you to take that number and multiply it by 700,000, blah 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 blah. All those zeros just muddy up the water and make it really tough to do, because you gotta keep the zeros straight. So some guy came up with what's called scientific notation, and it's really easy to do. There's like 3 steps here that you just have to remember. Step number 1, okay, is you have to move the decimal so that the number is between 1 and 10. That simply means this. And it'll take me a while to explain it. When you actually do it out, it's really fast. In other words, if I'm doing this 1,800,000,000,000 number, the decimal originally starts right here, but I am going to move that decimal so that the number becomes between 1 and 10. Which really, another way of saying it is, you need it to have 1 digit left of the decimal. That's not a 0. So that means I'm going to take this decimal and move it all the way to here. I'm going to make that number 1.8. I can leave off all the rest of the digits as long as they're zeros. If there were other digits here, like a 5 and a 4, I'd have to still write those down. But if there's zeros, I can leave them off. Got that? Step number 2 is you write down in quotation marks here, times 10. So I write that down. My step number 2 is just times 10. And then step number 3 is, for the exponent of 10, you need to write down the exponent of 10 is how many places you move the decimal. It's a good thing we have commas there, but you can count them out if you want to. I moved this decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places, and that's the exponent I put with the 12. This number, written in scientific notation, is 1.8 times 10 to the 12th power. Now don't forget, and this is the scientific notation. It has to be a number between 1 and 10 times 10 with some exponent by it there. And don't forget, this is really the logistics of what that is. If you're breaking this down, what is 10 to the 12th power? See, if I take 1.8 and multiply it by, how many zeros would 10 to the 12th power have, Brianna? 12. If I multiply 1.8 times a 1 with 12 zeros in it, I would get this same number I started with. So really what I'm doing with scientific notation is taking out all of those zeros so I don't have to deal with them when I do calculations. And you're not going to do multiplication division with them right now. You're just learning how to put it in scientific notation so that you can do that later. So it's a pretty simple, it's a very, very simple, uncomplicated sort of thing. Examples. 1500 in scientific notation would be, well, where would the decimal go? Between the 1 and the 5. It's always times 10. You always write that down. And what would my exponent of 10 be? How many places did I move it when it started here and ended up there? It moved how many places, Lainey? 3. 1.5 times 10 to the third power. This is scientific notation. Emily.
Can I get a chance to write my name?
I'll put it back up there in a moment. Now, in addition to writing stuff in scientific notation, you need to be able to take stuff that's in scientific notation and rewrite it back in standard notation. So if you are given something like this, 3.65 times 10 to the 8th power, how do you suppose I would make that in standard form? And please make sure you don't think that you just add 8 zeros on the end of this, because that doesn't work. You need to move the decimal 8 places, and 2 of those places get taken up with 2 digits that are already there. So in reality, how many zeros am I going to add on it? 6, because I need to do this. Here's my 3.65. I need to go 1, 2, 3, 4, 5, 6, 7, 8. Decimal's going to go there. All of these get filled in with the zeros. So it's going to be 365 with 365 with 6 zeros after it, and you know enough in your young age that you need to put those commas in there otherwise. 3.65 times 10 to the 8th power is 365 million in standard form. Standard form. Let me see what else they give us here. Yeah, they don't do that. Oh, they say this. Write this in science. What would 25, and then they throw a little curve at you because they'll say, what is 25 million in scientific notation? Side note. What would 25 million be in scientific notation? What would it be, by the way, in scientific notation? 25 Are you writing this down? Or not? Am I just doing this for my own personal liking? There's nothing better to do. You might as well write it down. What do we get for that? 25 million in scientific notation. I mean, it might be wise to write 25 million out first so you know what it looks like in standard notation. In scientific notation, Elijah, it is
2.5 times 10 to the 7th power.
correct. Move the decimal from here to there. 2.5 times 10. I moved it 7 places. It's not how many zeros there are, it's how many places you move the decimal. Or how about this one? What is 7.5 times 10 to the 8th in standard form? 7.5 times 10 to the 8th in standard form. In standard form, that would be standard form. People say that would be random stick drawn here. Standard form. Danny! 5 with how many zeros after it?
7.
1, 2, 3, 4, 5, 6, 7.
one of the zeros, one of the places gets taken up with the 5, and then you have 7 more zeros. So 715 million. Any issues, problems, concerns?
We get to small numbers too.